And the calendar over there. Minute. Quizzes. Left off on homework number 1.7. Oh my gosh. So bonus questions. There were 2 points for each correct answer and 4 points for showing the appropriate work. So there were 6 answers you had to give. 6 times 2. 12. Work 16. 16 points there. And then the other bonus was 4. 20 total bonus points out of 48. And then you did really well on the quiz. So some of you, you really set yourself up with a really good score going into the test eventually. So I'm going to hand these back to you. Litzy. Okay. Don't get complacent. Candace? Yes. Yeah. She's not just 29. And you had it, yeah. Otto? Great. And Salino. Super. So if you try in the correct quadrant, you know what sign to do. Okay. Red. Roger. And bring all that. Roger. So we left off 1.7. But we didn't do all of 1.7. This is why I have to take a picture of the board. We did part E. We did A, we did E. Okay. So let's do B, C, and D. B, C, D, F. B, C, D, F. Number 127, B, C, D, F. So number 127, F of theta is sine theta. F of theta equals the sine of theta, and G of theta is cosine theta. So 127B. G minus F of theta. So this is function G minus function F of the variable theta. So function notation means G minus F of theta, not times theta. This is not distribution. But what it is, it looks like distribution, but it ain't. It's G of theta minus F of theta. That's what this notation tells you to do. You subtract the functions with the value of theta. So in 127, you're supposed to let theta equal 7 pi over 6. So what you're supposed to do, so G minus F of 7 pi over 6 is G of 7 pi over 6 minus F of 7 pi over 6. And now you plug them into the actual function. You plug it into G first. G is cosine, so this is the cosine of 7 pi over 6 minus the sine of 7 pi over 6. You shouldn't have to use a calculator. It's an over 6. Over 6, 1/6, that's a reference, or that's one of our, hopefully you know by heart angles. 1/6 of pi, 30 degrees. The sine of 30, I know is 1/2. That means cosine would be square root 3 over 2. That's what I know. But 7 pi over 6 is in what quadrant? Quadrant 3. And if we're in quadrant 3, then both sine and cosine are negatives. So you're looking at 7 pi over 6 right here. Only tangent is positive. So this would be a negative square root 3 over 2 minus this would be a negative 1/2. So negative square root 3 over 2 plus 1/2. Because it has a common denominator, I bet in the back of the book, it would make one denominator of a 2, and it might be negative square root 3 plus 1, or they might actually write, since it's a positive 1, and then put the minus square root 3 second. Either way, both are fine. You can leave it as separate fractions like this. You can make it as one fraction like that. You can leave it like that. It's all the same thing. Okay? But it's knowing what to do with this. It does this. And then you're just plugging 7 pi over 6 into each one. Subtract. Now, B, C. C, G of theta equals theta squared. Or G of theta whole square. And I got my functions over there. So that means I'm supposed to take the function G of theta and square it. Well, g of theta on the inside of that bracket is cosine theta. That's what g of theta is. And then you square it. So what that means is, now look at this. Without the bracket, if you write this without the bracket, if you just put cosine theta with a square like that, that's not the same thing. If you write it like this, what's being squared is your theta. You square the theta, then you take the cosine. That's not what it's supposed to be. That's why when you either want to square the actual cosine, you have to put it not so much in a bracket, but technically in a parentheses. The reason why they're using brackets is because they already have a parentheses around the theta. So you would write that cosine, the whole thing is going to get squared. All of g of theta is going to get squared. However, in trig, you don't have to use parentheses if you write it like this: cosine square of theta. You put the square on the s for the cosine. The same thing with the sine. Sine squared of theta. Tangent, the square is on the end. Tangent squared of the theta. That means you're going to square after you take the trig function of the angle, then you square the answer. So we had, what's the tangent of pi over 6 tangent squared? That means you're going to take the tangent of pi over 6, and then you're going to square the answer. This way you don't have to write the parentheses. So the tangent of pi over, I meant pi over 3. I really did. So the tangent of pi over 3 is square root 3, and then you're going to square it, and square root 3 squared is just 3. That's what we're trying for. So here, we're plugging in, again, 7 pi over 6. So g of 7 pi over 6 squared is now the cosine of 7 pi over 6. And then you're squaring it. The cosine of 7 pi over 6 we worked out over here. Cosine of 7 pi over 6 was negative square root 3 over 2. So negative square root 3 over 2. And then you square it. A negative to the second is a positive. If you square your square root 3, you get 3. If you square the 2, you get a 4. So this equals 3 over 4. D. On D, we are doing f times g of theta. Is f times g of theta. And how you expand f times g of theta? It's f of theta times g of theta. You multiply the function together. So f times g of 7 pi over 6 is going to be f of 7 pi over 6 times g of 7 pi over 6. So you plug 7 pi over 6 into the f function, sine of 7 pi over 6 times the cosine, g of 7 pi over 6. So because it's in quadrant 3, they're both going to be negatives. Again, this is negative 1/2. This is negative square root 3 over 2. Negative times a negative is a positive. 1 times square root 3 is square root 3. 2 times 2, 4. And we did E, so now we're going to do F. G of negative theta. So G of negative theta. So G, if G of theta is cosine theta, then G of negative theta is equal to, is it positive cosine or negative cosine theta? Negative cosine theta, no. Positive. Sine and tangent, secant, or cosecant and cotangent, they are the opposites. They are the opposites. So on the little handout I gave you, no, yes, of course, I don't put things in here like I'm supposed to. I don't have the review sheet ready. Then again, it wouldn't have been, I wouldn't have been able to make copies anyway. So we don't seem to have paper on campus, which is disturbing. But I will post it on Canvas this evening. I'll show you what I'm working with on. I'm trying to write it up a little bit more like your actual test. And that's beneficial to you. Read the identities list. Did I print it out? The basic identities. Much no. Yeah, okay, thank you. I can't find it. All right. I handed this out last week. At the bottom, so you have all the trig identities at the top of chapter 5A. At the bottom is the sine of negative theta equals negative sine theta. Cosine of negative theta is positive cosine theta, and tangent negative theta would be negative tangent theta. The negative angle identities. But you could just plug in the number and you can see what happens. You just plug in the number, you'll see what is going to happen. This is the rule. So technically, when you plug in 7 pi over 6, G of negative 7 pi over 6 is supposed to equal exactly what cosine of positive 7 pi over 6 would equal. The opposite of 7 pi over 6, negative right here, would be the same as just positive 7 pi over 6. Okay? But if I plug in negative pi over 6, on this side, plug in negative pi over 6, I get cosine of negative 7 pi over 6. And I want to compare that to what the positive would look like. This terminates in what quadrant? Negative 7 pi over 6. Where is that going to terminate in? Quadrant 2. 7 pi positive terminates in quadrant 3. If I make a standard position positive 7 pi over 6, that's in quadrant 3. Because it's bigger than 1 pi, it's 1/6 bigger, so the reference angle would be pi over 6 in quadrant 3. Because it's negative 7 pi over 6, you have to go clockwise. That means you're going to do basically the same amount of opening. And if I go the same amount of opening, you're going to end up in quadrant 2. That's the direction of negative 7 pi over 6. And again, the reference angle is still pi over 6. Cosine in quadrant 2 is negative. In quadrant 3, it's negative. The pi over 6, the reference angle for each, is square root 3 over 2. So for this one, because you're in quadrant 2, the answer is negative square root 3 over 2. And for this one, because you're in quadrant 3, it's negative square root 3 over 2. I get exactly the same answer, whether I plug in a positive x value or theta versus a negative, the y's are the same, which makes it an even function. Cosine is an even function. Now, if we did our f of negative theta, okay, so we compare f of negative 7 pi over 6 with f of positive 7 pi over 6. Because f is sine, when I plug in the negative, because it's sine, sine is an odd function. I should get the opposite of this answer. The sine of negative theta is the opposite of sine of positive theta. So if I plug in negative 7 pi over 6, I should get the opposite of positive sine of 7 pi over 6. This right here, again, terminates in quadrant 2. In quadrant 2, sine is positive. The reference angle is pi over 6. So the sine of negative 7 pi over 6 is a positive 1/2. It's a positive 1/2. This terminates in quadrant 3 again. Reference angle is still pi over 6. Because you're in quadrant 3, sine is negative. So this right here would be equal to negative 1/2. And there's an opposite in front of it. A negative times a negative makes that a positive 1/2. F of negative 7 pi over 6 is the opposite of what f of 7 pi over 6 is. They gave me a negative 1/2. Opposite of that is a positive 1/2. Okay. Tangent is the same way. The tangent and reciprocals work the same way though. The tangent of negative theta is the opposite of tangent theta. Okay. So the only one where the sine is the same left and right of the y-axis is cosine. Which ones change? Sine and tangent. Now 1.7, going to 135. All right, 135. Meteorology. Fancy way of saying what? The weather. If you are a meteorologist, you are not looking for kryptonite or for little babies falling out of the sky. I just saw a bright bird. Anybody seen Brightburn? Oh, what a disturbing movie. Think of what if Superman was like an evil, like beyond evil. But as a child, grows up evil. Man. Wow. So the normal daily high for the temperature in degrees Fahrenheit in Savannah, Georgia, can be measured as temperature is equal to 76.4, that'll probably be degrees Fahrenheit, plus 16 times the cosine of pi times t over 6 minus 7 pi over 6, where t is time in months, with t equal 1 corresponding to January. So you plug in 1, that's January. Plug in 2, that's February. Plug in 3, that's March. Find the normal daily temperature, find the normal daily high temperature for each month. That means for January, July, and October. This function represents the normal daily high temperature. So when you plug in 1 for T, that is the temperature for January. If you want July, you got to plug in what to get the daily temperature for July? 7. So I'm going to show you how the calculator works. I'm going to copy this over there. You could do it by hand, but I also want to show you how this works. T is equal to 76.4 plus 16 cosine, parentheses, pi t over 6 minus 7 pi over 6, parentheses. Okay. So if we were just going to do this by hand, January, let T equal 1. So the daily average temperature is 76.4 plus 16 times the cosine of pi times 1 over 6 minus 7 pi over 6. So T is equal to 76.4 plus 16 times the cosine. So this is pi over 6 minus 7 pi over 6. What does that equal? So negative 6 pi over 6. So that's equal to negative pi. So the cosine of negative pi. Okay. Now, negative pi. Over here on the unit circle, -1, 0. Cosine is your x-axis. So the cosine of negative pi is -1. Okay. The cosine of negative pi is -1. So this is 76.4 minus 16. So the average daily temperature is 60.4 degrees Fahrenheit. Now plug in 7 and start all over. Plug in for the last month. They want October, you plug in 10.